In the grand symphony of existence, where stars are born from chaos and life clings to a fragile blue marble, what if the very notes of reality were composed with exquisite precision, as if by an unseen conductor? Are the fundamental constants of our universe finely tuned for life, or is it all a cosmic coincidence? Join us as we delve into this profound puzzle, questioning the fabric of everything we know. Today, in an era where quantum computers challenge reality and telescopes peer into the universe's infancy, the fine-tuning of fundamental constants isn't just esoteric philosophy, it's a cornerstone of modern science. It matters because it bridges physics, cosmology, and even theology, explaining why our universe supports complex structures like atoms, stars, and ultimately us. As we push technological frontiers, from AI simulating alternate realities to searches for extraterrestrial life, understanding fine-tuning could unlock new energies, materials, or even multiversal theories. It fuels human curiosity about our origins, challenging us to confront whether we're a fluke or part of a designed cosmos, shaping our future quests for meaning in an expanding universe. The seeds of the fine-tuning idea germinated long before modern physics, rooted in ancient wonder. In the 4th century BCE, Greek philosopher Plato pondered a harmonious cosmos governed by ideal forms, suggesting the universe's order implied purpose. Later in the 13th century, Thomas Aquinas argued in his Fifth Way that nature's regularity pointed to a divine governor, an early precursor to design arguments, but the scientific framing emerged in the 20th century. In 1913, Lawrence Henderson noted the unique properties of water and carbon enabling life, coining biocentric tuning. The modern fine-tuning argument crystallized in the 1970s with cosmologist Brandon Carter's anthropic principle at a 1973 symposium in Krakow honoring Copernicus. Carter observed that the universe's age and constants seemed anthropically selected for observers like us. This evolved through the 1980s with works like Barrow and Tipler's The Anthropic Cosmological Principle in 1986, quantifying how constants like gravity's strength appear precisely set. By the 1990s, discoveries in particle physics and cosmology amplified the debate, turning philosophical musing into empirical inquiry. At the heart are the fundamental constants, unchanging numbers defining nature's laws. There are about 26 in the standard model, like g, gravitational constant, c, speed of light, h, reduced Planck's constant, and alpha, fine structure constant, about 1/137th. These govern forces. Gravity pulls masses, electromagnetism binds atoms, strong force holds nuclei, weak force enables fusion. Fine-tuning means these values are exquisitely precise for a life-permitting universe. Imagine baking a cake. Too much sugar, it's inedible; too little, it crumbles. Similarly, if gravity were stronger, stars would burn out before life evolves. Weaker, no stars form. The anthropic principle posits we observe these values because others wouldn't allow observers. Compare to Goldilocks, not too hot, not too cold, just right for porridge, or in this case, protons, neutrons, and carbon-based life. The narrative unfolds like a thriller, with pivotal moments reshaping our view. In 1965, the discovery of the cosmic microwave background, CMB, by Penzias and Wilson confirmed the Big Bang, revealing a uniform universe requiring precise initial conditions. Then, in 1979, physicist Bernard Carr and cosmologist Martin Rees published a seminal paper quantifying fine-tuning, showing how ratios like the electromagnetic to gravity strength, 10 circumflex 36, enable stable atoms and planets. A turning point came in 1998 with the discovery of dark energy via supernovae observations by Rees and Perlmutter, highlighting the cosmological constant, L, tuned to 1 part in 10 circumflex 120 for a flat, expanding universe. In the 2000s, string theory's landscape suggested 10 circumflex 500 possible universes, providing a multiversal explanation. Prepare to be stunned. If the strong force were 2% stronger, no hydrogen would exist. No water, no life. Conversely, 2% weaker, and multiproton nuclei couldn't form, leaving a hydrogen-only universe. The fine structure constant alpha, change it by 4% and carbon synthesis in stars halts, erasing organic chemistry. Lesser known, the Higgs boson's mass, discovered in 2012, is tuned to avoid a vacuum instability that could erase the universe in a bubble of true vacuum. And in 2023, studies suggested evolution might shape constants in a cosmological natural selection model, where black holes birth universes with inherited traits. Shockingly, some constants, like the neutron-proton mass difference, 0.1%, if reversed, would make stars explode prematurely. What if constants vary across spacetime? Theories like varying speed of light challenge uniformity, potentially explaining dark energy. The multiverse, from eternal inflation, posits infinite bubbles where constants differ. We inhabit a life-friendly one. If proven, it resolves fine-tuning without design. Alternate theories. Physical necessity, where constants derive from deeper laws or simulation hypotheses, tuned by programmers. What if we tweak them? Stronger gravity, universe collapses into black holes before life. Weaker electromagnetism, no chemistry, future implications. By 2050, quantum simulations might test mini-universes, or gravitational wave detectors spot multiversal echoes. Unsolved. The naturalness problem, why no huge hierarchies in particle masses, hints at supersymmetry or new particles at the LHC. Fine-tuning isn't abstract, it underscores our precarious existence, reminding us that a slight cosmic nudge could erase humanity. It impacts survival. Understanding constants aids fusion energy, combating climate change, or asteroid deflection. Philosophically, it evokes awe. We, fleeting sparks of consciousness, ponder the tuned orchestra that birthed us. Emotionally, it fosters humility. In a vast, possibly intentional cosmos, our lives gain profound meaning, urging stewardship of this rare haven. Echoing through time, luminaries lend weight to the enigma. Stephen Hawking remarked, "The laws of science contain many fundamental numbers. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life." Paul Davies affirms, "There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life." Martin Rees notes, "Our universe is what it is simply because we are here." And Fred Hoyle, upon discovering carbon resonance, said, "A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics." These voices amplify the cinematic depth, blending intellect with wonder. As we stand on the precipice of discovery, one question lingers. If the fundamental constants are finely tuned, who or what holds the dial? In this tuned tapestry, may we forever chase the echoes of creation, left in awe of the universe's whispered secrets.